Okay. So heat capacity tells us how much energy is required to heat 1 gram of one material by 1 degree Celsius. Specific heat capacity, okay, essentially the same thing. Right? Heat capacity is often to do with an object, where specific heat capacity has to do with a specific material. Okay? These questions will all have to do with specific heat capacity. They will all have to do with a specific material. Okay? These should be gimme marks on your unit exam. Okay? If you encounter a specific heat capacity problem out of 5 marks, there is no reason to not get 5 marks. They are simply that easy. Okay? This unit, okay, should be for everybody a gift when it comes to the unit exam, because there's practically nothing in it compared to the others, and everything that is in it is very, very easy. So I would suggest preparing very well over the next little while for your unit exam in this unit. It is a good opportunity to boost your marks significantly before your final exam. Okay? Remember, you only have 4 unit exams, and they count for a significant portion of your mark. If you do really well on one, it can bring up your average on all of them. Everybody follow me? Okay? But again, it's on you guys to do that work and make sure you know how to do this stuff really well. And then the same stuff will appear on the final exam. Okay? All right, so for this one, how much heat? So heat is energy. That means we're looking for E. We don't know what it is. Okay? Remember that the formula we use for a specific heat capacity problem is E equals mc delta T, where m stands for mass in grams. Okay? C is specific heat capacity in joules per gram degree Celsius. And delta T stands for the change in temperature. And like any other delta we have dealt with in this unit or in this course, okay, delta means final minus initial. Okay? All right. So if I'm solving for E, I don't have to manipulate this formula. I just need to plug in all the givens I have. All right? Is needed to raise the temperature of 150 grams of water. If it's in grams, it's mass. Okay? 150 grams. Okay? And they give us the heat capacity of water, 4.2, okay, joules per gram degree Celsius, from 5 degrees Celsius to 85 degrees Celsius. So delta T will be 85 minus 5, which is 80 degrees C. All right? So I've got M, C, and delta T. Solving for E is very easy. All right? I just have to multiply them all together. 150 times 4.2 times 80. Okay, 50,400 joules for my final answer. Okay. How easy is that question? Pretty easy? Okay, very easy. That would be a 4-mark question on an exam. Okay? 1 mark for givens. Okay? 1 mark for the formula. 1 mark for plugging in your numbers. 1 mark for the answer. Okay? Gimme marks, for sure. All right? Anybody need that one anymore? Okay. All right, write this one down. Second type of heat capacity problem. Basically, guys, I'm going to show you all the different manipulations of the formula. Okay? Manipulating E equals mc delta T should be pretty easy. All right? Give a minute to write that one down. All right, so let's look at this one here. So what material is a 100-gram cup made out of? So if they give us something in grams, once again, that's mass. Okay? If it takes 4,200 joules of energy, okay, so they gave us E, to raise the temperature from 12 degrees Celsius to 62 degrees Celsius. So delta T equals 62 minus 12, okay, which is 50. Okay, degrees Celsius. All right, so even if I didn't know which variable I was supposed to find when I first read this question, is it fairly easy for me to figure it out now that I know which ones I actually have? All right, the only one I don't have is C. All right, so anytime they're asking you what material, they're asking you to find the specific heat capacity, because specific heat capacity is a physical property. All right, same as the physical properties we did in that first lab of the year, right, where we used the physical properties of those unknown substances in order to identify them. Specific heat capacity is a physical property that is unique to each material. All right, so finding the specific heat capacity will allow us to use the chart that you just received on that worksheet to figure out what something is made out of. All right, so we know we have to use this formula, E equals mc delta T, but I need to isolate C. So how do I get C by itself? Okay, but how do I manipulate it? Right, I divide everything else except for C. I want to leave C here. So I divide both sides by M, divide both sides by delta T. Okay, and I've got E over M delta T equals the specific heat capacity. Now I can plug in my numbers, 4,200 joules divided by 100 times 50. Okay, one thing you have to be mindful of when you punch this into your calculator, the bottom does have to be done first. Okay, otherwise your calculator will go 4,200 divided by 100 and then multiply that number by 50. You want to divide 4,200 by whatever 100 times 50 is. Okay. Okay, so our specific heat capacity is 0.84. So if we look at that sheet that you guys got, okay, 0.84 corresponds to glass. Okay. Okay, and the units here are joules per gram degree Celsius. How do I know that that's what the units are? Well, the answer is I just know it because I've memorized it. But for you guys, okay, you got to look at what did you punch in here. You had joules on the top. This was in grams, and this was in degrees Celsius. Joules over grams degrees Celsius. Okay, everybody follow me there? If you're ever in doubt, always look at what the units were when you did your mathematical operation. Okay, so the material is glass. Caroline. Yep. Okay, questions? Okay, write down, sorry, don't have a third example there. I should. We'll write down a third example. Let's do this. Yeah, iron. Okay, so have you copy that one down, and then I'll show you how to do it. All right. So to solve this one, okay, we know that the things that are part of this formula, okay, E equals mc delta T, okay, mass, specific heat capacity, and temperature change. Is final temperature part of any of this? No. Well, sort of. It's kind of part of temperature change, agreed? If I wanted to know the change in temperature, I'd have to know the initial and the final, right? This question gives me the energy, okay, 4,000 joules. It gives me the mass, 50 kilograms, which needs to be converted into grams, okay? And it tells me the initial temperature, right? It also tells me what the stuff is made out of, so I could go to my chart and figure out what the specific heat capacity is. All right, so let's first write down our givens here. E is 4,000 joules. Okay, our initial temperature, so TI, is 5 degrees Celsius. Okay, our specific heat capacity for iron is what, 0.120 or something like that? What? 0.46? Oh, I was way off. Okay, 0.46 for iron. Okay, and that's joules per gram degree Celsius. And our mass is going to be 50,000 grams, because there's 1,000 grams in a kilogram. Everybody with me so far? All right. So the one thing I don't have right now is change in temperature. So that's what I'm going to solve for, because that's what I can solve for, at least at this point. Okay? I'll worry about trying to figure out what my final temperature is once I have the temperature change. Okay? So I want to get temperature change by itself, so I'll divide both sides by m times c. Okay? And in doing so, now I've left temperature change over there. So I'll have 4,000 joules, okay, divided by 50,000, okay, times the specific heat capacity, 0.46. All right, so is this going to be much of a temperature change? No, in fact, very, very little, because this is a big, gigantic bar of iron, okay, and it's not being heated by very much, right? So I probably should have picked better numbers. Okay? That's what happens when I pick them out of my head, though. All right, so 4,000, okay, divided by 50,000. Okay, times 0.46. All right, so I get 1.7. Whoops, I had 40,000 up there. Sorry. So I should get 0.17 degrees Celsius as my temperature change. All right. If my initial temperature was 5 degrees Celsius and my temperature changes by 0.17 degrees Celsius, what's my final temperature? Yeah, 5.2 or 5.17 degrees Celsius. All right, is that very hard? Okay, that's as hard as they get. Having to do that extra step is as hard as they get. This one might be a 6-mark question. All right, everybody with me there? So manipulating this formula is really, really easy. Whatever it is you're looking for, divide everything else away. Okay, unless you're looking for energy, in which case it's already set up for that. Everyone follow? Okay, so this is even easier than the mole equation. Okay, it's even easier than V equals D over T. It's certainly a heck of a lot easier than law of conservation of energy or the acceleration formula or any of that. Okay, so math shouldn't be a problem for this particular topic. Okay, questions there? All right, you now have a worksheet in front of you that has a whole whack of those kinds of questions. That is what I want you working on right now. I'll go over any ones that give you trouble. Okay, we'll see how we do on that. We may move on to latent heat today. All right, so let's stay focused on the task at hand. Right, Cam? And get to work on that worksheet. Yes. Yep. Okay, guys, let's have a look at number 1 here. Getting quite a few questions on this. Biggest thing is you got to write down your givens, and you got to know what units everything comes in. Okay, so we got someone stocking shelves here. She reaches the back door, finds the temperature of the door has risen 50 degrees Celsius. What were we just given? Change in temperature. Okay, anytime we're given something in degrees Celsius, it's most likely change in temperature, especially if it says risen, fallen, or changed. Okay, so that's delta T, 50 degrees C. All right. The door has a mass of 10,000 grams. All right, M is 10,000 grams. Okay, and the fire has generated 230,000 joules of energy. And if they say energy, that probably is E then. All right, so I have E, M, and delta T. I know my formula is E equals MC delta T. They want me to find the material the door is made of. The only thing that will tell me material is the specific heat capacity. It's also the only one of those things I don't have as a given in the question. So if I want to find C, I move everything else, M and delta T. So E over M times delta T, okay, will give me C. So all I have to do then is go 230,000 joules, okay, over 10,000 times 50 degrees. Right? And when I do that, I should get 0.1 something, or whatever iron is there. Sorry, 0.460. Okay, and that'll come out to iron. Everybody with me on that? Big thing is to write down your givens. Once you have your givens written down, what you have to do with E equals mc delta T is like that. Okay, it's automatic. Okay, keep going there, guys. Okay, so on number 5, we want to cool down our coffee by 10 degrees C. All right, that's delta T, 10 degrees. Okay, she has 1 kilogram of coffee. That's a whole liter of coffee. That's 1,000 grams. Okay, and the coffee loses 40,000 joules of energy. Okay, what's the specific heat capacity of the coffee? All right, so I have delta T, I have M, and I have E. I'm looking for C. All right, so I divide both sides by M delta T because I have both of those. And I plug in my numbers. 40,000, okay, divided by 1,000 times 10 degrees. Okay, that gives me 4 joules per gram degree Celsius. Okay, any others? Deb? 3? Okay, so we're stirring soup at the cafeteria. The spoon has gotten 5 degrees warmer. Delta T. 5 degrees Celsius. Okay, her spoon has a mass of 0.008 kilograms. If I want to convert kilograms to grams, I do what? Not divide. There should be more grams than kilograms, right? So I multiply. All right, so the mass is 8 grams. Multiply by 1,000. Okay, and then it has absorbed 50 joules of energy. So I have E, M, and delta T. So it's exactly the same as number 5. Okay, we're looking for the specific heat capacity of the spoon. So that'll mean then, okay, that we have E over M delta T. So 50 divided by 8 times 5. Right? And so we should get 1.25 joules per gram degree Celsius. Okay. Any other ones? Okay, keep going then. Okay, so for 14, okay, space shuttle lifts off, okay, using 200 million joules of energy. Okay, if the pad is made of concrete, so we need the specific heat capacity of concrete, which is what off of your sheet there? 2.9. Okay, 2.9 joules per gram degree Celsius. We know the energy is 200 million. Okay, joules. And it has a mass of 500,000 kilograms. So there it is in kilograms. 3 more zeros. Now it's in grams. Okay, and then all we have to do is find delta T. So delta T will be E divided by M times C. All right, so our 200 million, okay, over 500 million, okay, times 2.9, and that'll give us 0.13 degrees Celsius. I'm sure it's more than that, but again, sometimes I pick numbers out of my head and they don't work out real well. Okay, I'll make sure that on the test, any ones I give you make sense. Okay. Any other ones? What do you suppose tomorrow's quiz is on? Yep. And it's posted, so you can check it. Okay, at some point tonight, maybe right after you get done your climatograms thing. Okay, remember that does not need to be submitted on Google Drive. That can be handed in, okay, on paper to me tomorrow.